Hey ladies and gentlemen, geometry midterm review for the spring of 2013. This is part 7. We're working on volumes and surface areas, and hopefully this will take us from problem 53 through the end, problem 62. Again, we're talking about shapes, volumes, and surface areas. Here we go. Also, just as a note, all of the, if you find a mistake, bring it into me. That you got to be in my class for that to apply. I apologize if you're from another class using this. Hopefully I don't make a mistake, but unfortunately life happens, especially rushing through it as quickly as I am, so that we can get through this. Don't worry, your midterm is not this long, but this just is, make sure you get plenty of practice so that you'll rock the midterm when it comes. Identify each solid. That is a cone. That is a cone. We also have right prisms, which I'll just go over it for the sake of it. These are right prisms. Okay. We also have pyramids. These are pyramids. We have cylinders. Those are cylinders. We've got spheres. Those are spheres. Just for identifying. And then sketch and label with indicated measurements. The net of each solid. Remember, the net is if you unfolded the piece. So if I unfolded the cone off of that base, I'd still have a circle. And then if I unrolled that base, I'm still going to have, you can make it look like that. So when I fold this edge over to this edge, I'm going to get that cone shape and then flip it up on top of the base. Measuring, that's 4. This edge right here then would be the 5.4. That's going to be your slant height. The other way you could look at it is you've still got your base, because I can flip that top part off, and I could do, this is not looking like I wanted it to. Let's try this again. Okay, you could do that, where you've slid it and you've unfolded it and you end up with something that looks like that. This still being 41.2, this still being 10. Because then when you fold it, this edge you'd fold over onto this edge, and you'd make that cone. The base would fall into a circle. Same general idea. So there's the nets. Also, make sure you look at the last review for that last test, the Chapter 6A, Unit 6A test. Had a lot of problems with practice nets. So there's more if you need help. 53. Find the surface area. Remember, surface area of any right prism is the area of the base times 2, because I have 2 of those, the area of 2 of those pieces, plus the perimeter of the base times the height. Just a reminder, the base is the shape that I can cut this in a million pieces, the same parallel cuts, and end up with essentially a stack of post-it notes. That the base is whatever shape I'm going to end up with that's the exact same. That's a really poor explanation of it, but we went over it in class. I showed you solids, I showed you shapes, we cut them. Okay, so hopefully that just jogs your memory enough. And then the height is the height of that stack of pieces. So if I make this little rectangle my base right here, I can cut it a million times like this. I'm going to end up with a stack of a million of those same identical rectangles, and the height of my stack is going to be 11. So let's do that. Area of the base, this is a rectangle, so my area is 2 times 7. There's my big B. That's my big B. That's the area of the base. I've got 2 of those, plus the perimeter, which is 7 plus 7 plus 2 plus 2 times the height. Remember the height of that stack, so that stack is 11. And that's going to give you your surface area. Don't forget, that's going to be in miles squared when you work that out. Over here, 54, let's use a different one. Let's use this side one as the base, because when you have a rectangular prism, pretty much any face can end up as the base. Here, let's make this big one so it's easier to see. We'll make that the base. Imagine cutting it into a million slices like that. Each slice will look just like this top. That's how you know you found a base that works, is I can slice it just underneath that base, and I end up with another base that looks exactly like this top piece. So, area of my base, again, it's a rectangle. 6 times 2 is the area of my base. I've got 2 of those, plus the perimeter of that base, 6, 6, 2, 2. 6 plus 6 plus 2 plus 2 times the height of that stack of bases, 3. That gives you your surface area. Again, don't forget, it's kilometers squared. Area. Okay? Here, there we go. I have a triangular prism. Actually, this is still a right prism. My bad. Looking at the next one. Okay, there's my base. The reason this top triangle is my base is because I can cut parallel to that top 1,000,000 times, and every time I cut, I'm going to end up with a piece that looks just like this top. If it changes, then it's not the base. Or if there's another way I can cut it, but again, I'm getting ahead of myself here. So, same thing, surface area is 2 times the area of the base plus the perimeter of the base times the height of the stack of bases. So, here, I've got the area of the base. Well, this is a triangle, so the area of my base is 1/2 times the base of that triangle, which is 11, times the height of that triangle. Remember, we're talking about the triangle, not of the whole shape. Okay, so there's my base. I've got 2 of those. Area of the base times 2 plus the perimeter, 9 plus 11 plus 5. There's the perimeter of that times the height of that, times 2. There's your setup for the surface area of this right prism. Triangular prism. Same basic concept. I've got area of my base times 2 plus the area of the perimeter of the base, I can't speak today, times the height. So, area of the base. Again, my base is a triangle. Notice here, that's a right triangle. That'll come in real handy in just a second. So, the area of my base is 1/2 times the base of the triangle. Not the base of the whole thing, but the base of the triangle. So, notice, if I use this, I can use this as the base of that triangle because the height is the one that comes straight down. Well, let's try that again. I can use this as the base of my triangle because the height is the one that comes straight down from a vertex and makes a 90-degree angle with that base. If I use this as my base, then I would need to find what line comes straight down and makes a 90-degree angle with that base of 5. So I'm going to use this side, which we know from over here is 4, and that as my base height of the triangle. I need 2 of those, plus the perimeter of the base, which is 3 plus 4 plus 5, times the height of the stack of bases, 7. There we go. Move so you can see it. So I have the area of the base, 1/2, times the base of the triangle times the height of the triangle. I've got 2 of those, plus the perimeter, 3 plus 4 plus 5, times the height of that stack of bases. Pyramid. We're dealing with surface area. Again, just as a reminder, if we ask you for the volume of a pyramid this year, we will give you the height. We're not going to ask you to find that for this midterm. Surface area. Again, my base is right here, and the surface area of a pyramid is a little bit different than the surface area of a right prism. Surface area of this is the area of the base plus the perimeter plus 1/2 of the perimeter of the base times the slant height. L usually represents slant height. So, and this is surface area. So the surface area is the area of the base. Triangle, so I'm going to have 1/2 times the base of the triangle times the height of the triangle plus 1/2 times the perimeter, which is 9, 9, 9, 9 plus 9 plus 9, times the slant height of the pyramid, 11.3. Work that out, find the algebra, or do the algebra, you'll end up with the slant height. Here, same deal. I've got the base, and I gotta find a different angle. I'm trying to sit down here, and I can't see. So, here's my base. So, again, 1/2 times the area of my base. So this is my area of my base, 1/2 times the base of that triangle, which is 12, times the height of that triangle, which is 10.4. That's my B right there, plus the 1/2 of the perimeter of the base, which we said was 12 plus 12 plus 12, times the slant height, 6.9. There's the setup for the surface area of this. Volume, okay, so it says surface area and volume of each of these. Surface area of a cylinder is the area of one of the bases, which happens to be a circle. So we have the area of that, pi r squared, and we have 2 of those. So I'm going to multiply that by 2, because I've got the top cap and the end cap, and then add that to the circumference of the circle, which is 2 pi r, times the height, which in this case is going to be 6, but that's just the general height. So surface area here is equal to 2 pi times r, which is 1 squared. 1, that being the diameter, so the radius being 1, plus 2 pi times 1 times 6. Volume of a cylinder is equal to area of the base, pi r squared, times the height. So the volume is equal to pi times 1 squared times 6. Again, surface area is going to be yards squared. Volume is going to be yards cubed. Over here, surface area is equal to 2 pi times the radius, 7 squared. Because again, there's pi r squared, that's the area of the base. I've got 2 of those, plus the circumference, 2 pi r, which is 7, times that height, 12. There's your setup. Volume is equal to pi r squared times the height. Sphere. Surface area of a sphere is 4 pi r squared. So the surface area of this sphere is equal to 4 pi r, don't forget they gave you the diameter, so you got to cut that in half, squared. Volume of a sphere is 4/3 pi r cubed. So the volume of this is 4/3 times pi times r, which we said was 12, cubed. Let's see. Same here. Surface area is equal to 4 pi r, 9.8, squared. Volume is equal to 4/3 pi 9.8 cubed. Now, just as a reiteration of, okay, so what are they talking about when they say they want the actual, let's go back up to the instructions, the actual and in terms of pi and the approximate decimal. Okay, so I set these up. I'm just going to do one of these real quick to show you, okay, what am I talking about exact? What am I talking about approximate? So let's do surface area. Move it down. So I've got surface area was 4 pi r squared is 144. 144 times 4, 576 pi. Surface area, centimeters squared. That's what I mean by exact. Work it out. Let's do the volume in exact too, because that one has a fraction. So the volume we said was 4/3 pi times 12 cubed. Well, 12 cubed is 1728. Simplify 1728 times 4/3. That's 1728 times 4, which is 6912 over 3. Make sure you can't simplify that. So can that be simplified? Yes. 3 goes into 6912, 2,304 times. 3 goes into 3 once. You don't have to write it with that over the 1, but you can. So there's the exact volume, so that's centimeters cubed. If I say approximate, then I say, okay, you can do this one, 576 times 3.14 to represent pi, and I get the surface area is approximately 1808.64 centimeters squared. Here, 2304 times 3.14, 7234.56 centimeters cubed. And again, this is volume is approximately equal to. Any questions? 576 and 73. Yes, okay, just double checking my answers. So there's, sorry, asking for questions is redundant, but whatever. Exact, approximate, exact, approximate. And hopefully that concludes everything. Good luck, and see you all Thursday and Friday for your midterm.